We're seeing an increase in the death rates of corals through extreme events. Used to be like 5 to 7 years between bleaching events, but what we saw over the last decade was massive escalation in the damage that was occurring. At the same time as also seeing back-to-back bleaching. No time to recover. Corals dying faster than they can be replaced. If these things continue to poke through that threshold, they'll get too warm for reefs to survive.
Today I'm joined by marine biologist and climate scientist Ove Hoegh-Guldberg to discuss the current state and future risks of Earth's coral reefs. Ove Hoegh-Guldberg is Professor of Marine Studies at the University of Queensland in Brisbane, Australia, where his research focuses on existential risks to Earth's marine ecosystems. Ove was one of the first scientists to identify the serious threat posed by global heating to coral reefs in a landmark paper published in 1999, which predicted the total loss of coral reefs by 2050. In this episode, Ove provides an overview of the fundamentals of coral reefs, the most recent data on ocean acidification and coral bleaching trends, and the risk that we all face if we lose these vital reef ecosystems. These small but mighty ecosystems play an outsized role in upholding biodiversity and ocean systems as we know them today, a topic which is very important to me personally. A reminder, if you'd like to learn more about the information presented in this episode or any episode, I encourage you to take a look at the show notes, which you can find on our website, thegreatsimplification.com, and at the link at the bottom of the description of this episode. The show notes include valuable resources and references and are available for every episode in our catalog since episode 1. Lastly, before we begin, if you enjoyed this podcast, one of the biggest ways you can support us is by subscribing to it on your favorite platform and sharing this episode with someone who might also enjoy it. We believe in making this content free and accessible to as many people as possible, so we appreciate your support. With that, please welcome Ove Hoegh-Guldberg to discuss coral reefs. Ove, welcome to the show. Great to see you.
Good to see you too, Nate.
So the status and importance of coral reefs in our world is a topic that in the 3.5 years of this podcast, we have not yet covered. But many people I know in my inner circle feel that this topic is incredibly important for understanding the state of our biosphere. And as Johan Rockström recently said, the health of the coral reefs are a canary in the coal mine. And so I've invited you here today because you have decades of experience communicating and researching this topic. In fact, in prepping for this, I discovered you were one of the first scientists to identify the serious threat posed by global heating for coral reefs in a paper published over 25 years ago in 1999, which predicted the loss of coral reefs by 2050. So let's begin this interview there with an update. As we're now halfway to that point. How has this prediction held up until now? What sort of signs and guideposts and symptoms are we seeing from reefs about their overall health and stability?
Well, it's really interesting because when I was writing that paper in 1999, I sort of came to a point where it was sort of very gloomy, to the point where it'd be unbelievable. And in fact, many scientists wouldn't really support the conclusions at first because it just seemed incredible. You know, this is 25% of the biodiversity of the oceans lives in and around coral reefs. They're hugely important to people, ecosystems, almost everything in the, tropical world. And to the idea that this would disappear was sort of, incredible, really. It couldn't be possible. And of course, I sort of concluded in the end that it will just have to get this out there and follow the process of science, debate this really important issue. And if at the end of the day I walked away with egg on my face because I was wrong, that would be the sweetest egg I'd ever had. Right?
I know the feeling.
That's right. And so put it out there, and and I was a young lecturer at the University of Sydney, and suddenly there was this sort of immense spotlight on everything. And I remember some of the, press releases and so on got quite spirited and felt really quite strange, sort of going through this as a young lecturer. But in the end, it's just really shows that science is really, really important to resolving these questions like, global heating and acidification of the oceans and so on. And so at the end, it's like, well, yeah, this is happening. Now, that was sort of, in fact, I was working on coral bleaching for my PhD at UCLA, in the early 80s. And so, I was sort of building up this sort of understanding of what was going on. And so it eventually came to a point where it was sort of, this paper had to be written. It was written, and then sort of second part of my career sort of started to unfold, which was, defending this, but also then trying to drive the research to understand what was happening and what we must do to sort of avoid it. As part of that, I also made some predictions, that by mid-century we would see the loss of coral reefs in great numbers. And when I was doing this stuff with my PhD, it was very much a sort of a localized phenomenon, and people were saying, what's this thing going on? It's a disease, or is it some physical variable, or is it, what is it? And it turned out that temperature was the predictor, and temperature is so good that you can actually project where coral bleaching is going to occur just on the anomaly in temperature above the long-term summer maximum for a region. And so when you looked at those sort of issues, you start to build up this picture. Well, are we on track? Unfortunately, yes. When we look at, just the last decade, remembering this is not seen in the scientific record prior to the 1980s. And then you look at where we are today. So it was sort of, the occasional bleaching event that occurred in that early phase. But what we've just experienced over the last decade is sort of, 6 massive coral bleaching events that are sort of off the scales, killing large amounts of coral and causing, so yeah, I got it right, unfortunately.
By getting it right, you mean we're on the trend that you predicted, and so you still believe that by mid-century, which is only 25 years from now, we might, like a human who is alive in 2050, will outlive coral reefs.
Yeah, and that's where, if you look at things like the Intergovernmental Panel on Climate Change reports, a couple of years ago, they, the consensus, I was part of the experts reviewing the evidence, was that if we restrained sea temperature to, to global warming, to 1.5 degrees Celsius, we'd still lose sort of between 70 and 90% of the corals we have on reefs today. So that overall abundance would drop. That if we missed that opportunity and restrained ocean temperature to 2 degrees above, the pre-industrial period, we would see sort of 99%. And of course, if you go to 3 degrees, it's really questionable as to whether reefs in any way, shape, or form are going to be there. And of course, that has implications for enormous numbers of issues.
So I've had probably a dozen podcasts on this platform about ocean issues, but I've not had someone talk about corals, and I know very little about them. How long has the planet had coral reefs, and how do we know that?
Well, corals create perfect fossils in a way, right? Because part of their biology and signature, I guess, in the fossil record is, large amounts of calcium carbonate being precipitated, principally as aragonite, to build these skeletons and so on. So when you look at that, you can go back several 100 million years, and you've had this persistent calcareous structures which form coral reefs. And of course, that structure explains the biodiversity. So, if you look at a coral reef and you just blur your eyes and just look at the calcium carbonate, it's full of nooks and crannies for life to create the little the driver of biodiversity. And so you look at that and you say, well, actually, okay, so we've got very similar things over hundreds of millions of years, and that type of structure in today's oceans, and in fact, with the other fossils that are found there, you find this plethora of life, and that's pretty hard to argue against. But what's really amazing is that this hairless ape from Africa has been able to sort of organize the collapse of this enormous ecosystem. It's just incredible.
Yeah, we'll get to that later in the program. So are there evidence in the 5 previous mass extinctions? And my ecology nerd friends tell me there's been over 10 prior mass extinctions, depending on the definition. But how did those events, especially the ones caused by lava basalts and volcanic outgassing that raised the temperature and the acidity of the oceans, how were there die-offs of coral reefs then, or do we know anything about that?
Yeah, well, I mean, we know that there were things like the Cretaceous boundary event, which, from what I understand, is sort of explained by a huge crater near the Yucatan in Mexico. And during that period, you had the loss of 90% or more of coral types and of course of the life associated with coral reefs. So you're really looking at major changes. Now they're in a different class really to, I suppose, what we're seeing today. I mean, I think if I'm just to predict, if humans no longer have an influence or suddenly get their act together in terms of the stewardship of coral reefs and of life in general, then you're likely to see the recovery of reefs over long periods of time. But this gets to the question about the sort of discussion of what's important, and for the 500 million plus people that depend on coral reefs today. A Cretaceous boundary event would wipe things out, and of course, but also you could see things come back over time. But it's the disruption to people's lives which is most important, now.
So I have you're probably not too familiar with this podcast, but now I have a lot of questions to ask you here. So 500 million people in let's just say 99% of the reefs are killed. And we're going to get into the mechanisms why. But 500 million people, their livelihoods would be displaced. Why is that?
Well, when you look at those people, and these are people throughout the tropics, there's a large number of people that depend on coastlines to provide food, livelihood, resources, cultural significance, and so on. So it's that immediate need that humans have, to fill out the basic essentials. But of course, if you take away the reef, which people go out on a daily basis to collect their food, to then go back and provide some income to take the kids to school, or if that's possible, you're looking at a whole range of. It's a vulnerability.
Well, it's interesting that and horrifying that we hear about climate refugees, and the expectations are in coming decades that could be in the billions. But when we talk about climate refugees, we're talking about unable to live in a wet bulb temperature above, a certain threshold. But we're not talking about necessarily the 400, 500 million people that depend on the reefs for food under those similar warm conditions. So this is a subset of climate refugees, you might argue.
Yeah, no, definitely. And it's just horrifying when you think of that number of people being dislocated just in the issue of coral reefs, into large cities and to urban centers, because it's a sad dislocation of their lives.
I want to get into what is coral bleaching and how does that actually happen. But there's been a lot of data and headlines in the last few years about the declining health in coral reefs. before I get into that science, how are you and your colleagues and scientists around the world, how do we actually measure the stability and abundance of coral reefs? And how far back does this data reliably go?
Well, I suppose one of the challenges, I guess, is to get a regular update on corals in terms of abundance, because that sort of, is at the nub of the issue. To get that, of course, requires coordination between nations. So as the coral reef crisis developed, there are a number of initiatives that were designed to sort of get a handle on that. And one of those was the United Nations Coral Reef Monitoring Network, which was designed to sort of 30 nations coming together in its initial stages to sort of understand how biodiversity was, how the quality and abundance of coral reefs was varying. And so it was a bit spotty and not the best data in the beginning. But when you look at that particular group and then you look at the efforts that countries like Australia and the United States have made to, underpin that sort of measurement, you're dealing with probably very good, it's a really good understanding of what's going on. And what we're seeing is that, for example, over the last decade, something like 14% of the world's coral reefs in terms of abundance have disappeared. And so, that has implications. And of course, there's been responses of international agencies and so on that have increasingly focused on it. But there are really, I think there are very, very good things. I mean, just this week, we've seen the release of the latest long-term monitoring project from the Australian Institute of Marine Sciences, where they look at the Great Barrier Reef and other reefs like Ningaloo in Australia. And they have provided a very, very good understanding. Of course, there is, some years there's an increase and other years there's a decrease. But what we're seeing is that it's becoming much more violent in the swings and that it's really starting to sort of disappear. And so, for example, reefs that I work on in the southern Great Barrier Reef for a long time weren't being affected. And that was sort of very interesting to understand why it was sort of more a phenomenon of the lower latitudes and so on. But we suddenly see high latitude reefs like this one at Heron Island on the southern Great Barrier Reef just what happened over the last sort of 24 months has been, well, it's been heartbreaking, but it's been truly transformative. Those coral reefs we were claiming were doing well fell over, and this gets to these issues like tipping points, and we're starting to investigate things that are pretty interesting in that respect.
So let's get right into the science of it. So one of the main risks, and not the only risk to coral reefs, is through coral bleaching. So what is coral bleaching? How does it happen? And how does it affect the health of corals? This is a generally scientifically literate audience, but just assume I'm like a teenager that's curious about this as you explain it.
Well, I think the first thing to know about corals is that they're not just corals. And in fact, they're underpinned by a wonderful mutualistic symbiosis between tiny brown single-cell dinoflagellates that live inside the gastric tissues of corals and a range of other organisms. And that association explains the tremendous productivity and diversity and so on of coral reefs, because you're essentially with this very efficient symbiosis where the algae capture sunlight and provide the food from that to the coral host, and in return the coral host, this is an oversimplification, it's very but essentially the coral host provides nutrients to the algae. So there's, algae are producing the photosynthetic products, and, the nutrients, the phosphates and ammonia and so on are then nourishing the algae. And that turns out to be the ultimate, get out of jail free card for corals as tropical organisms. Because one of the problems about the tropics, which is why we go to the tropics to see the beautiful clear water, is that they're very, very low in nutrients. So if you can keep those nutrients within this sort of animal dinoflagellate coral host association, you can thrive in a nutrient desert like a coral reef.
And then the dinoflagellates and the corals themselves create the ecosystem for many more creatures and shelter and its own productivity and everything.
And this goes right back to Darwin, because it was extraordinary to see the greatest biodiversity in the ocean occurring in essentially nutrient deserts.
How is a coral born, or how does it start and how does it grow? Does it start with just a tiny, well, I don't know how it starts, please.
Yeah, no, it's really interesting. And it's a fascinating story. Corals are cnidarians, which are sort of simple animals that, have, create these things. And so, I mean, for a long time, people didn't really quite understand, the biology of corals until a group of students at James Cook University in Australia realised that one of the most spectacular events in nature occur on the reef, and that is that over a couple of nights, practically all of the corals and many other organisms spawn together, essentially to overwhelm the predator net. These are things that are going to pick off the larvae. And so they produce millions of eggs and millions of sperm and bundles and all sorts of, biology there. But the bottom line is that this thing happens over a couple of nights and you just have this tremendous sort of explosion of the next generation of corals and so on.
And then the ocean currents take them to other areas.
That absolutely. And so they swirl around and, you have... you go down to the beaches after the spawning has occurred, and it's just piles of sperm and egg and this sort of the smell of washed up, not so successful sort of coral babies.
The smell of coral sex in the morning.
Yes, exactly.
So then if they find the right conditions in a nutrient sparse environment, then eventually some algae will find them and it'll grow and it'll be the size of a mushroom. And then 100 years later, it's this huge reef because it's growing and taking nutrients and expanding.
That's right. You've got corals being among the most long-lived organisms on the planet.
How long do they live?
Generation times can be between sort of 3 to 5 years to as much as sort of 100 years. And so you have corals, which scientists now sort of drill cores of, those things are 500-600, years old. So you can really get weekly temperatures, for example, of corals going back, hundreds of years. And so that's been really important, understanding whether these temperatures we're seeing on reefs are actually normal or not.
So even in normal temperatures, normal cool ocean temperatures of the last few dozen millennia, corals die from old age or something.
Yeah.
But then they're recreated elsewhere, maybe close by, and it's just this constant cycling. And we're concerned about the net amount of coral right now on the planet. Of living coral. What happens when they bleach?
So you've got this symbiosis, and you've got the algae living in it. So in many ways, it's a knife edge existence. It's sort of finely tuned so that you've got one organism living inside another, and you just think of the evolutionary steps, the co-evolution that needs to happen for that to be, viable. I think means that they're the first organisms to start to show stress when you push the boundaries. And so what you see there is that the dinoflagellates don't work as well. They start to produce antioxidants and active oxygen and things like that. And so the response of the host is, with this sort of mutualistic relationship starting to break down, is to to lose the zooxanthellae. And so early in the understanding of this phenomenon, it was sort of, people were saying, well, that's a really tiny amount of temperature change. Surely not. I mean, 1 or 2 degrees above the summer maxima over a month is enough to cause bleaching to occur. And in some cases, if it returns to normality quickly, corals will then regain their algae from algae inside the tissues, not necessarily from the outside, and then go on as they had before. But increasingly, as we've seen these escalating amounts of thermal stress, we're starting to see corals that just outright die. They just get too hot and die. And so it's not so much bleaching, it's just coral death.
But if corals are bleached, they're more susceptible to death in the near future, correct?
Yeah, that's right. Yeah, I mean, there's interactions between those variables.
So here's something that I didn't think about till just now. So it's not an absolute temperature limit like, I'm sorry, I still am in the States and think in Fahrenheit. And the water temperature, once it gets to 88 degrees, corals die. It's the relative to what they're used to. Is that correct? Because I believe that there are thriving corals in the Red Sea, and the temperature there is quite a bit warmer than in Florida or in Australia.
Yeah, so we explored this, phenomenon years ago, where and some of the scientists in the sort of network translocated corals from the top of the reef, to the bottom. So it went from where corals were at 2 degrees higher than those at the bottom. And when you mix those up and then had a bleaching event, you saw those corals that had been translocated from the warmer sections of the reef survived the bleaching events on the southern Great Barrier Reef because they were genetically, it would seem, adapted to the local temperatures at some scale. So for the Great Barrier Reef, if you go from that warm north to the cooler southern part, you have a 2-degree temperature difference, and that's reflected in the sort of, the genetic tolerance.
When you say 2 degree, you would say the average temperature of the water there during the year.
Yep, that's right.
So 2 degrees Celsius is actually probably quite a lot.
Yeah, absolutely. And so what you're seeing then is you're seeing the sort of, there's that aspect, and then you've got probably a little bit of acclimation that goes on as things change. The bottom line seems to be that if you push them beyond that sort of temperature that they're normally experiencing, you get that bleaching. And of course, the situation in the Red Sea is really interesting. In fact, the Israeli and Jordanian scientists that have been looking at it, we've been in collaboration with them. And at first, I was like, because one of the principals was a postdoc in my lab for a while at the University of Queensland. At first, I was like, this can't be so. They always bleach, when they get 1 to 2 degrees above the summer maxima and for a region, and so be it. It turns out in the Red Sea, though, there's a very unusual situation with this, 1,000-mile Red Sea, where you've got a tiny little, in the most warm parts of that reef, down near Yemen and other, parts of that system, you're seeing waters being sort of 32 to 33 degrees Celsius. Yet up the top, you've got, temperatures that are more like, 27, 28. And so coral larvae coming through the bottom of the Red Sea go through a selection for warm genotypes only. They flood into the Red Sea, they mix up through the Red Sea, but by the time they get to the Gulf of Aqaba in the north, you've only got warm genotypes.
Is it possible that under a 1.5 degrees Celsius, which is my opinion that is in the rearview mirror, and 2 degrees Celsius and beyond, that there may be a selection for the warm water genotypes?
Yep, that's exactly what we think is happening. And it does stand to reason. I mean, what's really interesting about that is that clearly adaptation to local conditions takes time. So you'd think that over time they get up and get exposed to those cooler temperatures, they should be selecting for, more normal behavior in this sort of, realm.
Even if we do select for warm water genotype coral, your prediction for mid-century that 99%-ish of coral reefs will have disappeared still holds?
Yeah, because this is a very tiny part of the overall distribution.
Okay.
It does, though, start to address the issues of scale, because there's a lot of science being done, with all respect to the people doing it, that sort of saying, okay, well, if we can find a supercoral and we can breed the supercoral and then we can sort of put it on the reef and off we go, problem solved.
Or in some places in the world, they're making artificial coral reefs and dropping them in.
Yep, that's right. And so, will that solve the problem of the loss of coral reefs? Probably not, because the scale, to replant corals onto the Great Barrier Reef, for example, which is 40,000 square kilometres of coral habitat that you'd have to replace. And you have, doing this at scale, you're starting to look at trillions of dollars.
Well, even if we were able to do it at scale, the environmental conditions, if we're at a 2 degrees Celsius average warmer water, they have no incubation. They have no rookery for baby corals to survive.
Yep. No, that's right. As I said, I don't want to demean the science being done, and we have to do some science to get an idea of this, but to claim that this is going to solve the problem is inaccurate.
So every time that I mention coral reefs and that a human child born today, will outlive coral reefs on this planet, I invariably get emails or comments in YouTube that say, no, according to the United Coral Global Watchdog, the extent of coral in the world's oceans is actually at an all-time high, or the Great Barrier Reef has a higher net or gross area of coral than ever before. And yet, when I talk to scientists like you, there's massive bleaching events, and the corals are not doing well and expect to be virtually gone in 25 years. How do you justify those statements? Is there some different quality that's going on in the coral? Or please help me understand that.
As we've said before, corals go up and down in terms of, no year is consistently in one direction or not. There's a bit of variability around that signal. And so if you look at it during a phase when it, for example, we talked about those reefs on the southern Great Barrier Reef, they were doing well. There was less stress. And in fact, the warming may have benefited the coral reefs. And so you've seen this in that region. You'd see this massive explosion of corals and so on and say, well, what's the problem? But of course, you've only got to look a couple of years later to see, that we've now swung back down. And this latest report from the Australian Institute of Marine Sciences, which is their long-term monitoring project on corals. Since 1983, they've been measuring the abundance. It's only when you do it at that sort of scale and intensity and time frame that you're able to see the big trends going through the system. I mean, that's informed also by lots of laboratory work that show that there are limits to the amount of, differences in sea temperature that corals can survive and so on. So all these elements come together to take just a snapshot look and say, look, see, it's all okay, is just naive from a science point of view, because this is a large-scale ecosystem that's sort of lumbering along through many parts of the world. And so, bringing together the great, the United Nations GCR, the Global Coral Reef Monitoring Network, and those types of information sources provide a much more sophisticated look at that issue. It isn't as simple as, yep, they're going up, problem solved.
But is it true that the extent of coral reefs globally is at an all-time high?
I don't know what the information source is, but I've seen similar things being said about the Great Barrier Reef.
Yeah, and is it true about the Great Barrier Reef?
Yeah, in some places, coral abundance has gone up from one year to the next. But in many places, it's gone down. And I think what we're seeing is we're seeing an increase in the death rates of corals through massive extreme events like not only is it temperature, but it's also big storms, for example, that are also having a big impact on reefs. And so you take all of those things together, we're getting more of the extreme events and less of the sort of positive bits where it's growing for a sustained period of time in an upward direction.
What about the quality of the corals? Like we could say that the country of Spain has increased its forest cover, but it's mostly monocrop plantations. It's not real forest.
Yep.
So is there an analog with coral reefs and the diversity and types of coral?
Yeah. So, if you go to a coral reef in the Indo-Pacific, you're looking at probably 500, 600 species of coral that go to form those mature reefs. And so it's a bit like, these projects of replenishing, we've been sort of doing our hardest to sort of get that diversity out there and so on and so forth. But you're probably planting something like 5 to 6 different species to create that structure. And yes, that's got some value. But it's a bit like planting Pinus radiata in the place of a mature rainforest. With the Pinus radiata is, a very low diversity system. It's probably got a couple of beetles and a couple of worms and, a bird or two, and there you have it. That's the ecosystem. Whereas a rainforest, of course, would have hundreds of species and a completely different scale of biodiversity and interaction. And you can't replace that, obviously, with a radiata pine forest.
So, forgive me, but you're a very mild-mannered and careful scientist.
Sure.
But how you led this off by saying 25 years ago, you wrote a paper saying within 50 years there would be no coral left. And now you just kind of said, well, it's growing. Some years it looks like it's growing. Some years it's not. And I get it, and I appreciate that you're a scientist and want to be careful. Yeah. But that doesn't jive with, in 25 years, all the corals are going to be gone, or does it?
Oh, it does. It does. I mean, one is the variability around a signal.
Okay.
Right? So you've got that ups and downs, good years, bad years, and so on and so forth.
But the trend is unmistakable.
The trend is unmistakable. But what I said before was you've got to be careful about, how you measure those things, because if you just have a spot check and go, yep, the corals here have survived, that means everything else is going to be okay.
And this is the problem with communicating incredibly existential science to the average person, because they want a binary yes, this, or no, and it's so nuanced in so many ways.
Yeah, absolutely.
Yeah.
So I agree. I mean, yes, I am being mild-mannered, but I'm being truthful to it as well. It's like, yes, it takes time to get a good fix on what's actually happening. So with these global networks, and all of the other information coming in that informs this space is heavily in the, it is changing, and it's changing very rapidly, and we will see reef systems that have very low, abundances of coral. Now, then you say, okay, well, will that destroy it? Yes, it will destroy it for the 500 million people that are depending on it, because they need the food today, not tomorrow. But over time, this will probably recover, and it'll be like the Cretaceous boundary event in which we lose a lot of species, but then, over time...
Well, over time, meaning hundreds of thousands or millions of years once
exactly.
Yeah,
exactly.
Right. But in any human timescale, they won't recover.
Yeah, that's right. Or,
because they won't have the conditions. Now, how much of the conditions is heat? And how much of it is acidity? We haven't talked about acidity much. Does acidity affect coral reefs?
Well, ocean acidification is this phenomenon where CO2 has it's not just a warming potential, it's got this interaction with water that's so important. So CO2 enters the ocean, interacts with water, creating a dilute acid. the the protons that are released then like to bind to calcium to carbonate, turning it into bicarbonate, which takes it away from its role in building the skeletons of corals.
So everything else being equal, a more acidic ocean, and the baby corals after they're going to grow much slower and be limited.
That's right. And so you're going to see, impacts on coral larvae, but you also see the ability to lay down the calcium carbonate skeletons, which create the infrastructure that, the 3D structure of reefs, which is really important to, the species living among the branches of corals and all of that sort of thing. That stuff disappears, and you start to see also the impacts on humans through reduced calcium, coastal protection and things.
Let's talk about that for a second. You've mentioned the 500 million humans might be climate refugees if the coral reefs go away, but let's talk about the broader biodiversity and ecosystem services that coral reefs provide. How much of the web of life in the ocean would depend on this, and what would happen to the broader web of life, maybe even dolphins and cetaceans and the fishes all the way up? What would happen if corals disappeared, even if everything else in the biosphere remained the same?
At one scale, the immediate effects may be delayed, for example. So the corals die, but studies have shown that the fish populations don't immediately respond. That it takes time for these things to plow through. And so over 10, 20 years now, we're starting to see the loss of coral reef fishes. Now, those fish populations are really important for supporting humans along coastlines. At first, you might see a couple of disgruntled divers and just, some of the fish are disappearing, but to the non-expert eye, you might not expect to see much thing. And so I've had a lot of situations where I've taken people who were just regular tourists out to see where I work in places like, and one of them was in the Cook Islands, where I worried while we went in to look at the reefs that they were all eaten by crown of thorns starfish and killed off by bleaching and so on, and that the tourists would be upset. But they came up going, "That was one of the most fantastic dives I've done. Did you see the turtle?"
Shifting baselines, maybe.
Yeah, it is. That's it. It's a perfect example, and in fact, I think Jeremy Jackson and others use coral reefs as a sort of the model.
But you wouldn't be guilty of shifting baselines, because I bet you've had hundreds or even thousands of dives in your lifetime. So when you were in 1990s, your doctoral studies on this versus today, what are you noticing? And maybe just for a moment, bring the viewer into the land of under the ocean surface and how magical and colorful and sacred that is. Maybe tell us a story about that.
I mean, when you do go below the surface, you go to a beautiful tropical reef and so on, and you go below the surface and you start to look at what's going on in front of you, it's a bit like going into New York, you know what I mean? Because there is just busyness everywhere. There's fishes that are, protecting a little piece of territory. There's predators that are working together to capture prey. Two different species working together to create opportunities in terms of just like in New York, right? It's just it lures you in, and it's fantastic. But at the scale of that city, if you take New York, for example, there's good and bad bits. There's beautiful art galleries going on over here, and then there's neighborhoods that are under threat over here. And that's just the same as on a coral reef. You'll find areas where it's under construction and other areas where it's under destruction. And it's the balance between those two forces which explains whether you're getting the outcomes we've been talking about or not. If you have much more destruction than you have in terms of construction, you're going to start to see those reefs sort of disappear and so on. And it could be very slow, but it's very fine.
if you have a, let's just use rough numbers. If you have a mile of coastline, and on that coastline, there's a couple of areas that have large coral reefs, and the rest of the coastline doesn't have coral. Will most of the small, medium, and large fishes kind of congregate surrounding the areas with coral because that's the base of the food chain?
Yes. It's fascinating when you go and see these things. I mean, there are places on the Great Barrier Reef where you've got algae, seaweeds essentially growing across the bottom. And so what you're seeing is the normal fish you see in those types of habitats where it's fishes that are blending into the background, so they're brown, seaweed-coloured looking things. But then suddenly you'll come across a place where there might have been a little bit more sea urchin grazing and so on, and so you've reduced the seaweeds. And out of that, we'll see beautiful, coral. It might just be a couple of meters of coral. But above that coral is this sort of all the fishes you see around corals normally accumulating.
So your reference to New York City might actually be appropriate. Corals are like cities in the ocean, with all the people and the busyness. I mean, not the people,
Yep.
the fish
Yep.
and all the things going on, and they attract travelers and all the things.
No, absolutely. And of course, that was picked up, in the various movies out of Hollywood with Nemo. That's actually, I remember seeing that film. And then I had to look at the leads because it was so accurate. It was, they'd created this sort of mythical cartoon universe, but it was so precise from the biological point of view.
So back to your work and the alarming trends that our mutual friend John alerted me to. I understand there have been several mass bleaching events in the past 10 years, including this year in 2025. Can you explain, Ove, what a mass bleaching event is in comparison to typical bleaching, and what is so important about these events happening more frequently?
So you have the disintegration of the relationship between the dinoflagellate and the coral host. And so just to pick up where we were on that, those corals can, in the days gone by, when I was doing my PhD, for example, we saw corals recover. They just get their algae back, they wouldn't have died. So that's bleaching. But then more and more have been dying outright. So it now gets just too warm, they don't lose their algae, or they lose very few at first, and then, they die. Now, what we've seen is, so if you can imagine, there is a threshold for each of those regions we talked about, which is the summer sea surface temperature. And what you see is that as you go above that, you have, a bleaching event and so on. And so in the past, we've recovered, used to be like 5 to 7 years between bleaching events. They only occurred in the El Nino years. But what we saw over the last decade was, two things. Was massive, escalation in the damage that was occurring. At the same time as also seeing, back-to-back bleaching. So, you had a bleaching event one year, and then the next year you had one straight afterwards. No time to recover. Corals dying faster than they can be replaced. And that then brings you into the sort of conclusion bit, which is, if these things continue to poke through that threshold, they'll get too warm for reefs to survive. And that's where we start to look at this. So when that number of 14% of corals having died over the last decade as being one of the things that the Global Coral Reef Monitoring Network, the United Nations agency that's looking at the sort of abundance of coral, that is a shocking thing, because in that city, that New York, it's like suddenly you decide you're not going to do any construction and you're just going to sort of mow down and, just let everything fall into disrepair. And of course, becomes a dangerous place. The wrong people, the wrong fishes are in the wrong spots. And it's,
So it's not precisely that 14% of corals have died. It might be that
Mm,
18% of corals have died
mm.
and 4% have been born and grew, but the
Yep,
net is a 14% decline. Is that
that's right.
correct?
That's right.
Yeah. And so what is the current status of the mass bleaching event that's happening right now in 2025, and which reefs is it mainly affecting?
Well, it's been working its way through the coral reef resources, and so we've seen another, period. I mean, earlier this year, I went to various places on the Great Barrier Reef for a look at how coral was doing, and you saw, up and down that region, you saw unsustainable amounts of coral bleaching occurring, and mortality, I should say.
For someone that's devoted their life to this and has predicted it, emotionally, I can imagine that's got to be difficult for you to go visit reefs that you knew
Yeah.
30 years ago and see what's happening.
Yeah, no, it is really tricky, and it's also heartbreaking when your children, who are also very keen on the ocean, are going to live into the predictions of their father. They're my kids, right? I mean, if you think about it, they're going to be, was Dad right? And I shouldn't say me. I mean, I'm talking about a whole
Yeah, yeah.
group of science and so on. But you know, Dad said this would happen. Has it happened? And I really hope, just like I did all those years ago as a young, young scientist, and I just hope it's egg on my face that there was a whole bunch of stuff that went on, which meant that reefs were not going to disappear.
Sometimes I marvel and I wonder which is more amazing, the fact that we evolved from simpler organisms or the fact that humans figured it out. And in the same way, I wonder which is more extreme of a scenario, the fact that a human born today will outlive coral reefs, or the fact that no one is talking about this or seems to care about it. It's really a profound disconnect, or maybe it's cognitive dissonance that a lot of people are aware of it and they don't want to talk about it. So Johan Rockström, who was recently on this program discussing planetary boundaries, recently warned at a climate conference that tropical coral reefs may have crossed their tipping point and are experiencing unprecedented dieback. So, Ove, for someone who's worked on this their entire career, have we reached a point of no return? Or is there still time to alleviate coral stressors in a significant way for them to recover on a human timescale sort of thing?
So here's one of the hard truths, I guess, and that is that even if we put into play all of the pledges about emission reductions and so on, so we've got those that are sort of planned and those that actually have been put into play, we're still headed towards 3 degrees above the pre-industrial period. Let that sink in. And then you say, what do we know about the tolerance of corals? And that is that, as I said before, it's, 1.5 above the pre-industrial. It's 70 to 90% of corals today, or the abundance, disappearing. By 3 degrees, we just, it will be there'll be no benefits coming from reefs that come close to what we've been seeing over this generation's of experience.
There'll be underground museums underwater museums, to use the city analogy.
Yeah, that's right. And that will be it. It'll be lots of remade Sir David Attenborough movies, about the wonder of these systems, but they will be in past tense.
So what would that, like, just to be emotionally graphic, under a 3 degrees Celsius world, and I still hold hope that it won't get to that level because I don't think we have that amount of fossil fuels. But I think 2 degrees is pretty locked in. I don't know. But under a 3 degrees Celsius world 100 years from now, what would today's coral reefs look like? Would the coral still be there? Would it just be like beginning to fossilize? Or, I mean, what would it look like?
Well, I think in terms of the structure of reefs. There's been quite a bit of work now done where, for example, a colleague who I'm married to, another marine scientist in the family, Sophie Dove, put together mesocosms of the future. So it's basically these fairly large tanks connected to the reef-crested Heron Island that changed the temperature and the acidity of the water surrounding these things and ran it for many years to see what would happen. And what she found was that, yes, there's corals dying and so on, but the shift in the carbonate balance was some of the most, concerning. The sediments were starting to break down at much greater rates than you would expect based on the literature. And that overall, flattening of reefs was profound and very, very final. Once you've lost that structure, you just have essentially a parking lot in the Joni Mitchell context. So you look at that, you go like, well, we are looking at a world which we are hurtling towards. And yes, the only humans didn't do corals in because probably corals will survive beyond, humans. Because corals are, after that Cretaceous boundary event, a lot of them, probably, because one thing I didn't mention, we talked about the sexual reproduction of corals, but they're also so-called asexual reproduction, where they break apart, they little pieces of coral then can grow into other coral colonies. And that allows you to you don't have to have sex. You don't have to meet another partner to have sex to create babies, to go into that thing. You can just literally break bits off yourself, or storms break bits off you, and so on. So, yeah, corals will out-survive us, which will be maybe some sort of penance.
How would that happen? Let's assume that we get to 2.5 degrees and we lose most corals, and then they're, with or without humans, the 500,000 years from now, there's biogeochemical weathering, and eventually the temperatures and CO2 levels come down, and all that happens. But there weren't corals alive during this time. So how does a new baby coral come about at that future date?
That's where I think this asexual reproduction comes in. The species persists until they go back to the density of the reef like today, and then you start to have the input of, that sexual component of reproduction.
So what is the fate of coral reefs, which you have predicted will mostly be gone by mid-century? What is the fate of coral reefs? Tell us about the health of the world's oceans and planetary boundaries more generally.
Well, I think it's a great worked example in terms of Johann's limits. We don't have an endless ability to keep going here as we get further and further away from the sort of norms of what we've evolved towards as a sort of ecosystems and people. You get to a certain point where basically things. A little bit of a push, and then suddenly the whole thing collapses. It's the tipping point that is probably of great, and the late Will Steffen, who really promoted this and so on, I think was correct in that we are going to see an increased things like coral reefs and the Amazon and places like this going to be okay, and then suddenly bang, that's it, and good night, and thanks for all the fish.
So a lot of these things, like I've had many recent guests on, now adding you to the list, where you're focused on a specific issue, in this case, coral reefs. I had Anastasia Marikeva talking about forest and biotic pumps, and I had a couple people, Carlos Nobre, talking about the Amazon. And in each case, you're talking about, let's protect this incredibly important piece of the natural world of our home Earth. And there are strategies to help these local things, like, for instance, in the Amazon, eat less beef, and therefore there's less demand for clear cutting to plant soybeans. But the unspoken grim reaper in all three of these examples I chose is the global CO2 emissions rising, which no matter what you do to protect I think you mentioned the Nindalu or something like that reef in
Ningaloo.
Nigalu reef locally to protect it in the best way you can, you still have this global phenomenon that is a human metabolism sort of impact that dwarfs those micro local effects at resilience. Is that correct?
That's correct. But I think it does push you in a certain direction, which I think clarifies it. And so what we're edging towards here is sort of, what do we do? What are the responses? And for me, taking coral reefs as a signature ecosystem, we have to do really, I guess, two things. And that is that we have to reduce emissions of greenhouse gases and CO2 as quickly as possible, right? There's every piece of that CO2 going to the atmosphere has a huge impact on the well-being of ecosystems and people. But once you've done that, we should be seeking out those reefs that are least exposed to climate change and protect them as if there were no tomorrow.
Are there reefs that are less exposed to climate change, and why would that be? I mean, the climate is a global phenomenon.
Absolutely. But it's the local scale oceanographic things. Like, for example, in Indonesia, there seems to be a lot of these sort of locations. And it's in an area, Indonesia is the archipelago stretching between the Indian and the Pacific Oceans, where there's upwelling. And there's all sorts of phenomena that are bringing cool water to the surface and thereby helping protect those populations. And so we're seeing, when you look at the stress overall, those regions are, and so they're the best places to put your dollars because they are limited relative to the scale of the problem. But put those dollars to have the reefs of the future to replenish those reefs.
So just in, hypothetically in a perfect world, let's say we do head for 2 degrees Celsius world, but in these locations that you're discussing, that the upwelling gives them a little bit more of a buffer than the Great Barrier Reef or the Red Sea or somewhere that doesn't have such a phenomenon. And so they're able to survive longer, especially if we protect them. Is it possible then, if those are the last stands of healthy coral in the world, that the coral sex in the morning populates and goes all around the oceans with the baby corals? I mean, does it it can go really far in the ocean currents?
Yeah, so it still takes time. I mean, estimates of the influence of a spawning coral here on other reefs nearby is on the scale of sort of tens of kilometers. So you have one season, coral releases eggs, those eggs then drift away, and then depending on the length of the generation times of those corals and so on, you might have faster or slower rates, but it's at that scale. So the reason for reducing greenhouse gases to zero as quickly as possible is very much about stabilizing the ocean. Because if we stabilize the ocean, then those adaptations that are developing and over time will have the opportunity to sort of move into a stable environment. If we continue, if we don't deal with that CO2 problem and we get to the point where it goes 2 degrees, 3 degrees and 4 degrees, then we have no option. So that has to happen. And so in talking to our political leadership in Australia, for example, I'm seeing, the pollies are getting it. And so they're starting to, log on.
But it's a global problem, right? I mean, Australia's barrier reefs depend on the coal being burned in China and India.
Yep. So it's got to be a vastly, we can no longer, we can't imagine, country X, make country X greater. I mean, that's a lunacy in today's world.
This is a rite of passage for our species, and right now we're going to fail, as I'm sure you would agree. But let me ask you this, Ove, as one of the first scientists to advocate on this topic 30 years ago, what have you learned about communicating science to policymakers and the public during that time?
Well, I think science has a very special role to play in making the blunt points. You know, I mean, it's really interesting. I mean, that's what we're designed to do. We're constantly trying to promote ourselves on the bodies of the other scientists. It's like this competitive world we live in. And so it's one of those things where that being able to come into and talk to ministers of different parties and say, this is what's going on. And of course, you're depending on this reservoir of science through the IPCC and other international bodies that just allows you to bring sense to the table. Because, politicians, of course, have to balance all sorts of other things going on and can't often be as honest as they'd want to be. We have the ability to be blunt, and I think that's really important right now. And now, once that's said, I think we also have to be nuanced in our behaviour. We have to also realise that not everyone's going to understand what ocean acidification is when they first come across it. That makes the world a bit more perilous, but it also means we've got a job to do in terms of communicating the science to the policymakers that will ultimately make the decisions.
Well, let me ask you this. I mean, I live in Minnesota and there's no coral here, although there are a lot of fossils that I find when I look for agates and stromatolites.
I did a sabbatical in Indiana. I know exactly what you mean.
Yeah. But where you live in Australia, there are coral reefs all around your entire country. So are the general population aware and concerned about this in Australia? Or is it like in the United States, the people that don't live by the coast don't think about the oceans much?
No, I think people in Australia do. And the difference is we don't have the same population in the center of our continent because we're sort of like the reverse of the United States.
So everyone lives on the coast.
We're all living on the coast, so we're living with the properties and outcomes of things. Bleaching events are serious. People go and see them, and the tourists don't turn up, and it's becoming an issue.
Is there a coral reef trauma anxiety groups that people have seen these bleaching events and they get together and grieve and help each other cope? I imagine that's a thing. Yeah.
Yeah, no, absolutely. I mean, during the beginning of the last 10 years when it started to really hook up and, started to really become an in-your-face, issue, leading scientists, remaining nameless, were crying because the ecosystem they had sort of become one with was now being stripped away and disappearing. And so, it's an emotional issue. I often wonder why I haven't felt like crying. And I wonder what that is, whether I'm insensitive or whether I really do believe in the the fact is that the game is not over, and that we through that dual reduce emissions and protect thing. I mean, if we could get that to scale, we'll have a world in which we can live in, which will have some coral reefs left, but not many, with the wonderful phenomenon of an expanding coral reef as we get to stability over this century. I mean, I see that as the big project we're on. We've got to get beyond the political cycle of 3 to 4 years. We've got to now start to look at and plan on a century basis. Now, if we do that, I think we lift ourselves up and go, things were bad and we didn't do the best things in the beginning, but look at what we're doing now and we're starting to see the changes. We've stabilized the ocean. We're starting to see, find those reefs that have the best chances of surviving the overall climate issue. And I think that, that is reason for hope and keeps me going.
So not to personalize this, Ove, but I actually recommend crying. I'm in my late 50s, and the only times I've cried as an adult is when my dogs died. But I've cried a half a dozen times in the last 9 months as I've become more and more aware and open to this, and I feel much better and actually much more creative and with a sense of meaning and purpose afterwards. And I've had a couple guests talk about grief and the like, and I think it's a real thing. Let me just not to put you on the spot, but the fact that you shared that you're married to a science colleague working on these issues, that's got to be both a blessing and a curse, right?
Yeah.
Because if it was a gardener or a kindergarten teacher, you just have different worlds, but you both understand the implications of the topic you're studying. That must be difficult to tune out. Do you guys ever just watch Netflix shows and do things that are totally unrelated to the severity
Crime
of this
shows.
topic?
Crime
shows. Yeah, I like those too. I like crime
and Sophie's
shows.
a genius at it. I mean, she's become a genius.
Yeah. Okay. So you
She
do laugh
she can watch like the first few lines of a film. Go, well, yeah, okay, that's the bad guy. This person
yeah.
isn't. You're gonna no. But to be serious, I mean, we do, and there is a lot of tension. I mean, we and especially in the fast-paced world of this, of these changes, it's we often argue about things,
Yeah.
about the reality of one possibility versus another. And she's trained in math and philosophy, so she's deadly in terms of dinner table debates. And I have to watch my step because, for example, for a long while I was talking about it being about bleaching, and she said, no, it's not about bleaching, it's about death. And she was right on the money.
Whoa.
And so it's a simple sort of a nuance there, but when we talk about bleaching, almost it's like an excuse.
It's like global warming. It's like this soft euphemism, coral bleaching. Well, we put bleach in to make our clothes cleaner. Coral death would get a lot more attention.
Yeah, and it has as a result, and so on. So, yeah, we've enjoyed lots of science. I mean, taking the kids on our expeditions when we used to do them every year. So they spent, on this island called Heron Island, which I've talked about before, and on the southern Great Barrier Reef. It's, a couple of football fields in size. It's an 8 square kilometre coral reef. It's mostly protected. And they would go up there every summer and run wild for 2 months, where you didn't have to know where they were because the island was very safe, and just had to tell them not to go into where the sharks were. But overall, it was just a sort of wonderful experience to have that family where Sophie and I were doing the science by day, and the kids were looking at the turtles laying eggs, or seeing the bat rays come in.
I can't imagine. I've snorkeled a few times. I've never scuba dived, and I know my colleague who we wrote a few books together, DJ White, one of the early Greenpeacers, and he runs Earth Trust. He's told me stories about the magical world of having some fins on and just spending a lot of time in these reefs, and it's a different world. And they're going away unless we change the trajectory. So before I get to closing questions, Ove, what can individuals who care about this topic, the world's coral reefs, and want to do something about it, what can they do to most effectively support coral reefs? Or is the answer to that all the same answers as global heating?
Look, I think, for me, we need advocates for the very reason you said before, which was that you look at the, people in Iowa or Minnesota or wherever in the center of America, there isn't that connection. And we're all connected to the reefs, ultimately. This is part of what we bought into as participants. This is this 25% of the biodiversity of the ocean living in and around this place that's no bigger than about 1% or less of the Earth.
Whoa, so 25% of the biodiversity in the ocean lives in 1% of the
Yep.
space?
Little bit. So
Okay.
you look at that, and it's breathtaking. Things like the euphotic zone, which you didn't talk about, the lower light areas of the reef, where every time you go there, you run into new species. So it's like Darwin gets to the Amazon, first, and it's like one of those things. So I mean, I think people that care about these types of issues. I mean, we should do our best to find to educate themselves on the issues, to take on board that issue that we have to reduce greenhouse gases urgently. This is going to be really important, because unless people that make the decisions understand that this is an important issue, they won't respond, or respond very little. So I think that's one thing. And I think also, it's just like, get to, use what the tools you have. If you're a filmmaker, go and make great films about this. If you're a writer, write great books about it. If you're a school teacher, bring this into the classroom. And not just coral reefs. I mean, they're just the narrative of a story which is being repeated across the planet, where it's about ecosystems falling over, tipping points, people, and so on. So, I mean, if we can get to that point where we start to develop a movement, then we start to change things at the scale that they need to be changed at. We can no longer open up, gas fields, coal mines, and so on. That day is over. The sooner we get off that, the better. And it sounds radical, but it's doable, right? The technology's there. I mean, that's the amazing thing is that we're still hugging onto the coal and so on, with these magnates, but it's now a dangerous product. So the best sequestration for CO2 is to leave it in the ground, leave the methane, leave the CO2.
So do you have, for the listeners of the program, beyond coral reefs, do you have any personal advice to the viewers of this show at this time of global upheaval and anxiety and worries about the ecosphere and the economy and polarization and all the things, what some might call the meta crisis? Do you have any general advice, Ove?
Yeah, look, I think the last thing we want to do is to lose hope, right? So we've got to look at the things that have been impacting us, and we've got to be careful about how we frame it, because, while we don't want to have false hope, there's plenty of reasons to be hopeful. For example, just the explosion in different technologies that we're seeing, and not to be a technology apologist, but we are rapidly expanding our ability to respond to global issues. It's like we didn't get it, and now we're on this escalation of activity. And so, I often talk to undergraduate audiences, and people say, well, it's all going to be dead by the time I get out of university, so, why would I want to go and study a coral reef or do something? And you go like, you're the generation that will fix things. You have it in your hands, and you have probably something that many humans that have existed have never really experienced, which was you've been able to save a planet. And it's a planet that is out there. There's only one in every 5,000 that's probably a planet that has life on it. So just join the fight.
Do you still teach, or are you primarily doing research on this?
Yeah, look, I still teach I used to run a course called Global Climate Change, and bringing in different people to talk to undergraduate audiences and so on, and also give lectures myself. So I love teaching, but of course it's the other is a full-time job as well. So
I love teaching too. So what, although I'm not doing it now, what advice do you have for teenage and early 20 humans who are becoming aware of all this stuff? How would you change your advice for young humans?
Look, I think some people think that the generation coming through should be a little bit more angry.
I wouldn't blame them if they were.
Exactly. That they have born into the world more or less on the assumption that there would be reasonable, like-minded individuals that would make sure that the resource wasn't destroyed, when that's quite the opposite. And so now we're seeing that, and now, I think it's not so much get angry, but it's get real on this and to really start to become active. Because to me, we talk a lot about this issue, and then, our ability to translate that talk into action dissipates just because of, the other things that people have to worry about. But really, I think it's really important that we get to the point where we say, all right, okay, here's what we need to do. Here's how we solve the problem. And it's a generational, it's a long-term process, but we can get there. Just have to start doing it. And of course, that's where I think, that can be uplifting when you think it through.
What do you care most about in the world, Ove?
My family, my planet.
Good answer. I don't know how familiar you are with my program, but I always ask this question near the end. If you could wave a magic wand and there was no personal risk or recourse to your decision, what is one thing you would do to improve human and planetary futures?
Yeah. No, I think it comes down to the dance we have with politicians. If we could have some sort of sprinkle dust, that you could suddenly have everyone speaking the truth, then I think we could sort of go, okay, that's where we're at. So now let's take those pieces and put it in together into a clever plan forward. But I think, that would be the ultimate fairy dust.
Then they wouldn't be politicians. They would be implementers or some different skill set than being a politician. But I agree with the sentiment.
That's right. Might even make them cry.
Yeah. So what are you working on? What is your main research and professional thrust right now on these issues?
Well, at the moment, I'm really interested in the sort of communication side of things. And so I've got a group that's working in my team that are creating online learning experiences for people in countries where it's hard to get that information normally, or people have not had the pleasure of going to university and so on. And the idea is that there's lots of people, for example, in Indonesia who haven't been able to have a degree and do the regular sort of, through to then looking out, running a department, on the environment, who, have had to sort of put it together as they go. And the idea is that these courses would be like to take blue carbon, for example, which is an important concept.
What is blue carbon?
Well, blue carbon is, it's basically recognizing the value of the ocean within the sort of global cycles. And so a big part of that is carbon that's associated with the ocean. And that has lots of opportunity for the future. But it's a hard concept to explain to a lot of people who have not been exposed to it. So the idea is that if you have a course on that, or you have, a simple course on who lives on a coral reef, and you do it in Bahasa, and it gives you a certificate at the end of the day, then there's this opportunity to sort of develop and help build an understanding and capability in this region, in that area. So it's a work in progress. I mean, we've had 1,000 students sort of enroll in our first series of courses. I can give you the website if you'd like, and so on.
Yeah. We'll put that all in the show notes. So, is there a research question that you don't know the answer to with respect to the oceans and coral reefs that you're really curious about that's relevant to the future? What is something that you'd really like to research, given time and resources that you'd like to understand?
For me, it would be trying to understand where the opportunities lie in harnessing the value of oceans in the climate question. And so I also did some years ago a project with the World Resources Institute on, the fact is that we often see oceans as the victim, when in fact they could also be the solution. And so this project, which was funded by the World Resources Institute, allowed us to bring together, together with a colleague, 20 world experts on shipping, on blue carbon, on all those different elements, and to essentially look for the opportunities. And the opportunities are really interesting. I mean, the top number one intervention was shipping. When we wait for our things from Google and Amazon and so on, they're all powered by this sort of fleet of boats, which is somewhere near 15 to 20% of the total emission budget. And so, what could you do with that? Well, replace the engines with, renewable energy, renewable sort of stored power and so on.
Or replace the demand for the things with less.
Yeah, and the combination, but this could be a real win for those things. And so, and the second of this was renewables at sea. So the idea of not only new technologies, but simply taking floating windmills and make them part of the ocean. That turns out to be a really sort of it's an area which could have a lot of promise in terms of reducing emissions. And so when you do that and then look at how much of the emissions that you need to shave off, the emissions that are pushing us towards 3 degrees instead of 1.5 degrees, that's between 25 and 30% of those emissions could be taken care of by off-the-shelf technology that can be, employed today. So those types of issues, to me, are really, really issues. I mean, they're not the science ones that I used to go after, and I'm really interested in still doing some science along the way.
Because the primary question about coral and the prognostications of people like you are pretty clear. So now your research questions are more on communication than science and implementing the importance of the oceans with humans.
Yep. Yeah. Yep. And spending a lot of time talking to politicians. I mean, I'm fascinated by that. And, at the moment, I think we've got a rare situation in Australia where we've got a strong Labor Party, a Liberal Party that's starting to reform itself, and a Greens that's very, pro-action on climate change. And so you look at those elements and you start to think, well, here is a moment when we need to make hay. The sun is shining. We've got some alignment. The Americans don't, of course. We understand that, but
yeah, I apologize for that.
Look, I know how wonderful America is, and I think this is the sad thing about it, is that you're now being tainted by a brush which not everyone owns. In fact, very few people, from what I understand. So, I mean, but for us, we've got this alignment, and I think this is the opportunity.
Thank you so much for your time today and your work over decades. And I hope that one day you do have happy egg on your face and that there are coral reefs by mid-century to be determined. Do you have any closing comments for people watching and listening who understand and agree with what you've laid out here today?
Well, I think it is keep the faith and get active and let's solve this problem together. And it's been really fun to be here, Nate, and it's interesting because it's not smooth. When you're asking those questions, it's sort of these are hard things to talk about in one sense, because we've been talking about it for so long, and we still have to have hope. And for me, it's great to have people like yourself guiding the discussion. It's just really important.
Ove Hoegh-Guldberg, thank you very much, and to be continued, my friend.
Oh, thanks, Nate. Bye.
If you enjoyed or learned from this episode of The Great Simplification, please follow us on your favorite podcast platform. You can also visit thegreatsimplification.com for references and show notes from today's conversation. And to connect with fellow listeners of this podcast, check out our Discord channel. This show is hosted by me, Nate Hagens, edited by No Troublemakers Media, and produced by Misty Stinnett, Leslie Batlutz, Brady Hyen, and Lizzie Siriani.